Hello guys, this is Yakov Fein with Farata Systems, and today we are continuing our series of Intro to Java video lessons. Today is lesson number 10, and we're going to be talking about stock price quotes. Stock price quotes is basically an example that I'm using to show you different techniques and different ways of getting the same thing in Java. We'll look at the URL class again. We'll look at the new to you technology called the sockets, and we will learn about how to do stuff with the RMI. In all these cases, we are talking about networking. So there are different services that allow you to get price quotes, stock price quotes from different markets, different exchanges, and if you are getting it from one of the free public sites, typically these quotes are delayed, 15 minutes delayed. If you want to get real-time price quotes, then you would need to subscribe to some service, maybe from your brokerage company, maybe from someone else, maybe directly from a stock exchange. But the point is, there is a way to get information about stock prices. How you can do it today, knowing what you already know. What do you know? You know a lot. You know, in particular, how to use the class URL from the previous lesson. And if you go to one of these websites, for example, finance.yahoo.com, they offer they offer data for free. Again, they may be delayed about the price quotes. If you will go to this site, you can either enter the price quote in there, or you can do this by specifying a particular URL. When you will be using that site, you take a look at the URL. It may look longer than what you see on the screen, but even this will work. This URL, the short URL, let's look at it. For example, finance.yahoo.com for IBM. If I'm looking at the price quote for IBM, right? Previous close, the price was $192. And if I will refresh this screen, the market is open now. It's Monday, April the 7th, and this is what it is now. So previous close price was $191. It was on Friday, the April the 4th, and today the prices are different. As you can see, they are changing all the time. But actually, see, I was wrong. Yahoo offers you real-time prices. It's 10:52 a.m. in the morning, right? And the price for 10:52, it's even better, right? So the point, what do I want? I don't want you to trade on the market. It's stupid. At least don't be a day trader. I've been there, paid my price. But I want you to see how you can programmatically get these data, not from there, not by looking at this website, but by running a Java program. So, but for now, just pay attention to this. It's IBM, it's a symbol or a ticker we call it, right? So let's change it to Apple. See, the Apple price is $525 and so many cents. See, it's down 6 points down. It's gonna get up. You know, Apple is a cash cow. But let's go back to Java. Back to Java. So if you know this URL, you can connect to it using the class URL. For example, like this, just like this. And then you can get an input stream out of this instance of the URL class, and then you know the drill, right? So you wrap it inside the buffered reader. If you are reading only the text, you can use this input stream reader for text information only. And then you need this content line by line, and then somehow you need to parse this string, the whole page, to eliminate all this junk and just get just a little piece of information that you need, specifically price for the stock that you want. But if you will do view source over here, right click, view source, or view page source, look at this, tons and tons of junk to be removed until you will find somewhere in there you will find the price for IBM, recent quotes, and Maybe you need to know what are the words for the last price. You can find it eventually, and but you see there is a lot of stuff to filter out. So it's not the best way. So we'd better find a decent data feed, short data feed without all this junk that comes with HTTP, HTML. And luckily, we have that. Yahoo offers us quotes in the CSV format. CSV, comma separated values, right? Comma separated value format. And if you will enter this URL, and inside you have to stick inside the symbol, the ticker for the stock that you're interested in, and you're gonna get short string, comma separated string of data. Let's try it out. I'll take the whole thing and I will copy it in my browser over here. It should be HTTP, of course. Not. And something was downloaded over here. See this? Let me open it up. By default, in my machine, comma separated value are opened by Microsoft Excel, but you see the price. It's today's date, April the 7th, 10:39. See, for this price, they give me the delayed price. See, I got 10:56, but they gave me the price that was 15 minutes ago, or what, 20 minutes ago? No, 15, 17. They show me that price. The volume, the quantity, and everything. So my point is that you can get a shorter data feed, and now you need to parse this data feed. You need to take commas out. And how you can do this? You can do it different ways. One of the ways is there's a class string tokenizer that allows you to specify what is a delimiter in a string, and the content between the delimiter is a token. And if you have comma separated values, then whatever is in between the values, what you're interested in. You can use scanner. There are different ways of doing these things. But the point is, we need to figure out what is the latest price for our stock, right? So let's do it. Hands-on. Walkthrough number 1, lesson 18. You need to go to that book site, right? You know that. And you need to download this lesson number 18, the source code for lesson number 18, and then you need to import it into Excel. Into Eclipse. Let's also start with E. I already did all that for you to not waste your time. So lesson 18 is over here, right? So what do I want? I want stock quote, the code. Check this out. What do I do in this class? I have a method called print stock quotes, which takes one parameter, symbol. So it's IBM, Apple, MSFT, whatever you know, AMZN for Amazon and so on. So what I do here, I create a URL by sticking the symbol right inside this string. I concatenate this URL from 3 pieces. First piece, then the symbol, and the suffix, like we did manually right now. Then what I do, I open connection, right? We did it last time on the last lesson. Then I'm saying, give me the reference to your input stream, right? And then I'm saying it's going to be text, so wrap it up inside the input stream reader. And then to make it more efficient, do it buffered read, right? So we got it, and then I'm asking the buffer, please read me the line by line. Actually, it's going to be only one line in this case. And then I'm parsing the line. I'm saying for this class, Java class string tokenizer, use the CSV string. I know it's comma separated, so use this comma as a delimiter. And please give me token by token. Next token. So the first token will be the ticker, IBM, Apple, and so on. The next token is the price. Maybe you are interested in trade date, trade time, maybe you're not. But the point is, it's gonna connect to that URL. It's gonna get the string, comma separated, and it's gonna parse it and will print it the price. That's all. Now, in the main method, we are we assume that the stock symbol will be given to us as a command line argument, right? For example, this IBM. And then we are taking this symbol and passing it to our function, to our method print stock quote over here. Then we stick it into the URL and so on. So let's try to do this. Right click, run as. We need to configure this application to run. Oh, I already did this. Okay, let me show you. I click on run, but let me do this configuration. I'll show you what it is. I want to run. What I want to run? I want to run the program. It's not. It's a different one. I want to run the stock quote in lesson 18. That's correct. And now let's give it a different symbol. IBM, for example. Otherwise, you're gonna say you're lying. Everything is prefabricated. No. This will be the thing. Run. See IBM. Price 192.65, and the date is today 4/7/2014, and that's for this time. 15 minutes delayed. See this? This one gives me 15 minutes delayed quote. It's 11 in the morning, and it gives me 15 minutes before. Right, so it works, right? So let's do a different stock. Which one you want? Tell me. Just tell me what do you want. What do you want to buy? Microsoft. Microsoft is a good company. They don't produce excellent software all the time, but it's a very, very MSFT, I guess they are thingy. Microsoft, $40. $40. It was at 10.45. What it is now, I don't know. Let's see. Let's go and see. I don't want Apple. I want MSFT. Oh. $39.97. That's what was at 11.01. All right, so you got the point, right? So that was the first way of getting the price quote, by using the URL and a publicly available service from Yahoo. Done. I am asking you to do a debugging to learn how the string tokenizer works, but you can do it without me because I already know this. Programming sockets. Second part of our lesson is sockets. Sockets is a connection. Basically, it's an endpoint at some server to which you can connect. Multiple clients running on different JVMs can connect to this JVM that run servers, and you can use this socket technology. Socket technology is a very fast communication, much faster than HTTP. It doesn't have all this overhead of HTTP, like HTTP request, HTTP response, lots of bytes, but it's a pure connection. It's a raw socket connection, we call it. And you're going to be using this TCP/IP protocol. Typically, TCP/IP protocol is a reliable protocol to connect to endpoints, so to speak, or a client with a server using sockets. There is another protocol called UDP based on TCP/IP. UDP is based on datagram. It sends chunks of data. It's less reliable than TCP/IP, and you can say if it's less reliable, if you can lose some chunk of data, why do you even want to use UDP? Because in some cases you want speed versus reliability. For example, if you're going to be placing orders to buy stuff and you will be putting your money on it, then of course you need reliable protocol, network protocol, and you want to make sure that everything that you are sending from the client machine will be delivered to the server. Or if it won't be delivered, then you know about it. Whereas with UDP protocol, it's different. If it's UDP, you can lose stuff. You can lose one of these datagrams, so to speak. So who needs that? Of course, not with financial application, but if you're streaming music, for example, or text over the internet, voice over IP, something like that. If a tiny bit of your voice will be lost, it's still okay, right? The user on the other end can figure out what you wanted to say. Of course, if it's a massive loss, then it's bad. But There are cases when you want speed better, you like speed better than reliability. So, anyways, what is a socket address? Socket address is a combination, a pair of IP address and the port. So we're going to be starting the server on a particular computer with particular IP address and on a specific port. I'll be running all these examples on my machine, which is port IP 127.0.0.1, and or you can refer it using the name localhost. Sorry. So if you will start the socket server, actually the name of the class in Java is server socket. It's for the server side. On the client side, you're going to be creating an instance of the socket class. Socket class will take its arguments the IP address of the server and the port. Server socket is start of the server binding to a particular port. If they match, hopefully, if there is no any other restrictions like security restrictions, they can talk. So this is a piece of code that you can do in the socket server. So you create an instance of the class server socket and you bind it, in my case, to the port number 3000. Then you say accept. When you say accept on this instance, you put the server into the waiting mode. Waiting mode, it's a blocking mode. Whenever a request comes to the socket, it's blocked until the request is processed on the server, and then it can process the other client's request. There could be thousands of clients connecting to the same server socket. It's not the fastest way of processing, of working with sockets, and there is a different package. I already mentioned that in one of the previous classes. It was java.nio, non-blocking IO. I mentioned it as a reference to the faster work with file access, but there are also classes which allow you to work faster with sockets. But this works, except, and it waits. Whenever the client connects to this socket server, then the code proceeds and executes some business logic that you put in there, and then the next request can be processed. So what do you do on the client side? On the client side, you create an instance of the class socket and you specify the IP address where the service was started, and hopefully it's still up and running and listens to the port 3000 in our case. That's the connection. And then you have to send data back and forth. We'll see the example in a minute. But what I want you to know that there is a new standard. It has nothing to do with Java sockets, but the fact that sockets are fast, they have no overhead, or not a lot of overhead. There is special technology which is included in HTML5 standard as well. It's called WebSocket. So when you connect from the browser to the server using regular HTTP protocol, there is a lot of overhead. HTTP request can contain hundreds of bytes in addition to your load, to your data load that is needed to your application. And when the server responds in HTTP protocol, it adds again several hundreds of bytes of HTTP response object on top of what you want to return from your application. So lots of overhead. So WebSocket allows HTTP sockets to WebSocket allows to upgrade HTTP protocol to WebSocket, and then the communication will be done in a full duplex way, so to speak, not like it was HTTP. Request, response. Request, response. Only it's a one-way street. With WebSockets, it's going to be in both directions. Data can go, it's a full duplex, data can go in both directions, and with a tiny, tiny overhead, like 2 bytes versus hundreds of bytes in HTTP. So it's a great thing, but our lesson is about Java. It's about different raw sockets in Java. But if you are interested in WebSockets, and I highly recommend you to look at it, then read the chapter 8 from our recent Orally book. It's still available online for free for now, but we hope you're going to buy it, right? Let's get back to our program. We want to look at the examples of getting stock prices using sockets, Java raw sockets. So what do we do? One JVM, say this is, let's call it a server. We're going to be starting a program there, the server, and we will be binding to the port 3000. The code to process requests from the client will be there, and all requests will go through the port 3000. And then we'll put the server into the listening mode with the invocation of the method accept. When the client requests the price stock quote, we will get it. In our case, we're going to be using random number generator. We will not be connecting to any stock exchanges, but we will generate a fake quote, like as if it's a real. It's not important for us. We are studying how to use sockets, not how to trade securities. So we're going to process the request and return the response to the client. The client is running in a different, separate JVM. In my case, I'm going to be starting on the same computer, but they could be definitely on different computers. So the client will create a different instance, not the socket server, but the socket class. You give to the constructor the IP address of the server and the port. Then you get a reference to the output stream of the socket. Right? So and after that, you're going to be in a home territory, so to speak. You will be working with the same I/O streams like you did with files. Over here is the same, actually. I didn't write it on top, but the server will do the same thing. Server will, when the client request comes in, the server will need to know how to respond or where to send the response to. So the server will also say, give me the reference to your output stream, and I'm going to give you the response. So the client gets the stream and sends the request to the stream. The server also gets the stream of the client and processes the request and send it back as a result. And in this walkthrough, I'm going to show it to you hands-on. Lesson 18, we want to look at the program. One of them is called stock quote server, and the other one is called client. Same project, Eclipse, lesson 18. I also want you to do something from the try it section from the book, but during this video I will not even go there. If you want, do it on your own. Okay, client. What the client does. As I put on the slides, we will run the client, giving the client a symbol. We are interested in the stock symbol, right? The price for IBM or Apple and so on. So what do we do? I am saying I want to connect to the local host, which is my machine, to the port 3000, assuming that we are already running the server over there. So somebody is listening on the port 3000, and then they know what to do with our request. And then I'm saying, give me the reference to the output stream, to your output stream, right? Because I'm going to be sending stuff to you. And give me the reference to your inbound stream, right? So because I need to get your responses, right? And then I'm going to write to the outbound, what do I want from you? I want from you a price for the stock that came to me through the args0 command line arguments, right? And when you deal with raw socket, there is no other protocols other than network protocols. There is no application protocols that would tell you that the whatever you wanted to send is already done. How to indicate to the server that you already send your request. You need to come up with some application protocol, and my protocol is whenever you send the word end, it means that you are done with sending requests. That's what I came up with. Right, so this is we are sending the request, and we start reading the response from the server using read line. We know it's a text, and as soon as we have the end word, then we understand that the server finished responding to us. When you will be downloading this code from the website, when I wrote it for the book, this line 33 looks a bit different. It looks if quote dot equal and then the word end inside the parentheses. Then I change it to this notation. I put the string value end first, and then I apply equals to it. Why did I do this? why it's better than it was before in the book. It's better because we want to protect ourselves from running accidentally into a null pointer exception. Imagine that if we had it written this way, say if a quote dot equals and then end. This is how you will see it in the book. If it's going to be like this, what if the quote is null? So we try to read the line right over here, but if everything is fine, everything works. But what if it's not? What if quote after that is null? We are gonna be blowing in here. In here we are running into a problem. We are trying to call a method equal on the null object quote, right? This is bad. Whereas over here, if I write like on line 38, we'll never run into this situation. We always call the method equals on the valid string with the value end. If the quote is null, then this value will not be equal to null. At least we will not get null pointer exception. Just get used to it, and whenever you need to compare a string with a value, then do it like I do now. Put the value first and then call equals on it. All right. That's the client. Now the server. Where is our server? Stock quote server. That's the guy, right? So this server, we are starting creating an instance of the server socket, and we are binding it to the port 3000. So it's going to be listening over there, right? And it'll print on the console, waiting for a quote server, quote request, so to speak. Then we put it in a listening mode with accept, blocking on the port 3000. After that, we are saying, say the client sends a request, right? As soon as the client sends a request, the program will continue going down line 23 and down. So as soon as we get the request, we get an object in the client variable, and then we are asking to this client, dear client, give me the reference to your input stream. Again, the same drill, chain it or pipe it with the input stream reader and then with buffered reader, and we are getting a reference to its input stream to get data from the client, right? When we're going to be responding to the client, we want to have a reference to the client's output stream, right? So we're going to be sending data over there, outbound in this case. So after that, we say, read the line from the inbound, what the client wants from us. We read the line, then we use random number generator. Java has a bunch of them. We generate a fake price and we send it to the outbound. We send this statement, the price of whatever symbol we got is so-and-so. Fake generated price. And we log it on the console. Alrighty. Let me see if I have anything running. Do I have? Yes, I do. Let me clean it up so we will do everything fresh, clean. So let me start the stock quote server. Right click, run as a Java application. See, I started the server. It's bound to the port 3000 and it's in the waiting mode because of this accept. No client's request yet, so we don't see any output over here. Now let's go to the client. The client requires us to configure command line arguments, right? So we will be able to pass a symbol. Right click, run as, run configurations. What do we want to run? We want to run client now. On lesson 18 project, and the arguments, let's do AMZN, which is Amazon. Apply. That's the command line argument for the client. See, client made a request to the server. Server did its fake job. It generated randomly the price and sent us back the price, which is this. Through the port, we connected through the port 3000. And by the way, I don't think I ever had a chance to show that Eclipse has more than one console. In this case, we are running two JVMs. First, we started the server, which is still up and running in one JVM, and now I started a separate program, which is a client. It's a different JVM, and accordingly, over here you can see different console. So this program is terminated. It's a client, which I did request just now. Actually, this is the one. Sorry, this is the one. This console is waiting for quote requests. This is a stock server. It's still up and running. It generated for us the price for the Amazon, but it's still waiting for the next request. And on this console, what I did, I asked for the price. If I will do it again, I'll get a new price for Amazon. In this case, of course, it's going to be completely different. Where did it get the C from? I was playing with the C. C is for the Citigroup, but which one did I run? Right click. Actually, it's from another example. Sorry, it's from another example. Right click, run as. Let me see. Again, right click. I don't see run as. Let me rebuild the project. Something is going on over here. Project clean. I want to clean all the projects. I have some leftovers running from the previous tests. I was testing these programs. Let me start it again. Stock code server. Right click. Run as Java. Started the server. Let me go here. Right click. Run as Java. Select existing configuration. Maybe it's a different configuration named client. Let me double check that I want to make sure that I'm running the right client, because I had a client for an RMI application as well. Configuration. I want to run this configuration. Main client less than 18. Oh, see, it's over here. It had C configured. It remembers that configuration. Let me do IBM. Apply. Run. See, for IBM, I'm connecting to port 3000 and getting the price. The stock code server was generating the price for IBM. So you got the point. Server is up and running. Client can connect and get the price. This was a socket technology, raw sockets. And as I said before, if you want to see how to work with sockets more efficient using Java and IO classes from this package, then read about it, learn it on yourself if you need to, or go through this nice tutorial by Jacob Jenkov. He shows you how to use non-blocking sockets. But we are moving on to the final section of our today's lesson, which is RMI, Remote Method Invocation. This was for years. It was whenever Java was created, this technology was created. It's not used that often these days, but it's there, it works, and I want to explain it to you. It also allows you to arrange communication between different JVMs. But it uses remote method invocation. The whole point is that it won't be connecting directly to the server. It'll ask first. It'll go to the naming service and it'll say, I want to find a service named so and so somewhere in the network. Could you please give it to me? That registry, the naming service, will give the reference to the service object wherever it is now. It may be yesterday it may be on this IP address and this port. Maybe today they decided to move it to a different data center with different IP address and different port. So the registry would know, the naming service would know where it is now. So first the client will ask the naming service, could you please give me the reference to the service object? And the naming service will find it and return it to the client in a special way, as a proxy or as a stub. And then when you look at the code of the client, I'll show it to you in a minute, then you will start calling methods in the client code. You will give names of the methods as if they are created on the client, but they are actually will be executing on the server. So the client's proxy for the method will internally connect to the server, call the real method over there, get the result back, and return it back to the client. You'll see it in a minute. But first, finding remote objects. Where to find the remote objects? How to find? You need to have the registry, so-called registry, and the client, RMI client, will try to find the registry. It'll be using naming service, which Java already has inside in the package java.rmi, and it'll say to this naming service, do a lookup for me, please. Find me a service named so-and-so. For example, price quote service, for example, or maybe quote service. The registry returns the object and the proxy for the service. Of course, for this to work, we need to do one extra step. We need to start the the RMI server in advance. We need to bind it to the registry, and we need to say, dear registry, my name is so-and-so, and if somebody will ask for me, just pass it over to me. Just imagine like a hospital, right? You want to visit somebody in a hospital. You go to the information desk or customer service desk and say, I want to see John Smith. He was having a surgery, for example. And they will do a lookup and say, oh, John Smith in the room number so-and-so. Maybe yesterday he was somewhere else on the recovery floor after the surgery, but now he is in the other floor, in the other room. Who knows about it? The registry, the customer servers, the customer service. So that's the same idea. The client asks the registry, where's my service? Get it, take it, use it. All right, so by default, if you the RMI registry starts and runs on port 1099. You can change it, of course, but typically it's 1099, the port. And the clients will ask the registry to do a lookup. Naming, there is a class naming. You will do naming.lookup, and you will specify where the registry is. And you will say, I want to find, you're going to be using, by the way, protocol RMI, and you're going to be saying, I want to find the service so-and-so, maybe price quote service. If everything is fine, if the service was started in advance, and if it was bound to the registry, under this name, then the registry will give the client the proper stub. And this is how it goes. Let's do one step at a time. First, what you need to do, you need to start the registry on some computer, right, on some server. Then you need to register the server with the service, I'd rather say, with the registry. So you're going to write a class in Java, which will be your main processor, which will include some business logic to get stocks. And you're going to be, when you will be creating an instance of it, you're going to be binding it to the registry. The registry could be run in a separate computer, or you can write a server in a way that it'll first create a registry and then it'll bind itself to the registry. You can do it this way, or somebody will bind it to the registry. But that's one JVM, or maybe two JVMs. You can run registry on one JVM technically, your server on the second JVM, and if you have only one client, it'll be the third JVM. And of course, you may have a bunch of clients. Anyway, so if this part is done, in my case, I'm going to be running in one JVM these two guys, registry and the server. Then I will start a separate program, which will run on a separate JVM, of course. So I will start a client program that will do a lookup. It'll connect to the register saying, dear registry, I need the service named quote service. Register will return a stub, a proxy, right? And then the client on that proxy will call methods which are supposed to exist on the service, like give me the quotes, or give me the Nasdaq symbols, or give me this, or give me that. This is how it's going to work. And we'll do it pretty soon. So, developing and running the app using RMI. So what do you need to do? You need to declare a remote Java interface. First of all, you declare an interface that is a sub-interface of remote interface. You declare in there the methods, business methods that are needed for your application, like get quotes or get symbols and so on. Then you need to implement these methods that you declared in the interface. You need to implement it in a class. What will happen next? I put in here 3 computers, A, B, and C, but all of them will be on my notebook this time. So computer A should start the register and register the server with it. That's correct. Computer B starts the server. Actually, I wrote the client application. We should remove it. I will be using the same the same computer, but server B technically starts the server and binds it to the registry. And the third computer could be running a client that finds the service from the registry and uses it. And let's do it. Walkthrough number 3. Download lesson examples from lesson number 5 from the textbook and add the following statement at the line 12. I already did it, but it's important to know. When you will download the code examples from the book, this line will be missing. It will be missing in the code. Well, that's why I'm asking you, add it over there. So this line will create a registry and will continue with the code with the server. So we will do this. Of course, you will need the import statement to the class for the local registry. And then you need to start the server that implement the interface with business method. When we will do this, you will see a prompt on the console. The quote service server is ready. We decided to give this name, quote service. Then we will leave alone that JVM, and we will start another program, which is a client. Right? We will start the client, configure the command line arguments to enter something, and then we will run the client, and we will start calling methods, calling stubs basically of the method that actually exist on the server. Let's do it. So now we need lesson 25. Lesson 25. The client. One more thing I forgot to tell you. The client will definitely take the name of the stock that we are interested in, but also we are passing a parameter, but not to our application, but to the JVM itself, to Java runtime. We are saying minus D is a property. We are saying I want you to use so-and-so security policy. Basically, you can, if you need to, you can restrict which clients can connect to my beautiful server. Maybe you can restrict them by IP addresses as well. But we will not restrict anything, so this is a default security policy that allows everybody to access my server. But it's interesting to see how you do this. I'll show it to you how you configure it. And now, what else do? I am saying to the naming service, which is sitting in Java RMI, the import statement in Java RMI. Where is the Java RMI? It's over here. One of the classes is naming service over here. See this? To be nice, I should have specifically state what am I importing. So I didn't do it because I was lazy. Sorry. But at least I explained it to you now. Naming class knows how to do a lookup. You're saying, I want you to do a lookup for me on the local host on the port 1099. Please find for me, there should be one of the services that go by quote service. I may have multiple services there with different names, but only one of them would go by the name quote service. All right, say I got it. If I got it successfully, then this variable will have stubs for all methods that were created on the server. And check this out. I'm calling a method getQuote, passing the symbol, right? As an argument. Where is this method over here? Do we have it? No. This class doesn't have a method getQuote, but we are calling a stub that will automatically connect to the real thing on the server, execute getQuote over there, get back the result, and pass it over here. Similarly, if I will enter the wrong symbol, maybe my server is tuned only to provide quotes for certain limited number of stocks, then I'm gonna get the message invalid Nasdaq symbol and use these. See, again, I'm calling a stub for the method get Nasdaq symbol. There is no such a method over here on the client. But it exists on the server. I'll show it to you in a minute. Now let's take a look at the server side of this RMI setup. Stock server. This is an interface. As I said, it has to extend the remote. And in there, you specify the business method that you are planning to give to the service. In this case, getQuote. And I decided also to create get Nasdaq symbols. Now we need to implement them, right? So to implement them, I wrote a class that implements stock service. This guy, to work it as an RMI server, you have to extend unicast remote object. And there's a different way to do this, but the simplest way is extend unicast remote objects. It knows how to deal with the clients. Anyway, so it implements stock server, which means that we have to implement the business methods that were declared in that interface, right? Get quotes and get Nasdaq symbols. This one and this one. Of course, if you are familiar with what's happening with Java 8 or JDK 8, you know that some method could have been done as default method, but let's not go there. So the interface declared two methods, and this class implements them. In this class, in the constructor, this is what I wanted you to do. I already did this. Look, I said, enter this line, locate registry, create registry 1099, and add the import statement. So this thing will create a registry on this port. What else? I created a collection array list of Nasdaq symbols, like say, these are the ones that I am allowed to use. And if the client will ask for any other than these symbols, then I'll say, dear friend, I don't know about it. I don't know about the prices. You can only call for prices of these particular stocks. Maybe it's our brokerage company and we are serving only limited market with limited stocks. So the implementation of the get quote, and by the way, you have to, when you use RMI and remote methods, you have to declare these methods that they may throw remote exception. So if something goes wrong remotely, the stub will get this notification and the client will receive the remote exception with certain explanation of the error. So what else do we do? If Nasdaq symbol, if we are able to find, we convert it to uppercase, but if we are able to find the symbol that we want, right? If it's one of these symbols that are allowed in our collection, then we do random number generator, we call it, to generate a fake price quote, right? And we return it to the method. Again, the method getQuote, the stub of this method will be called by the client, but communication between the stub and the real thing is done seamlessly for you, is done under the hood. Again, go back to the client. As you can see over here, we are calling getQuote on the client, but will call actually this method, remote method. And there is a get Nasdaq symbol which returns me which symbols are allowed from this collection. So let's try to do that. And now finally, the starter program. The starter program, we are saying we created an instance of that class that implements our methods. And we are saying I want to bind this instance under the name quote service to the registry. Naming rebind. Rebind, it's like bind, but bind it's initial when nothing is bound to the port 1099, but since I keep running the same example all over again, I'm saying rebind it. If there is something there, just unbind that and rebind the new one. So that instance of the class that I just showed you will be known to the rest of the world as quote service. So if somebody will do a lookup, they will get a reference to this SSI object. So when we will start the server, the registry will be up and the quote service is up, and we will see this prompt on the console. Let's run it. Run as. Yep, so it's up and running. I can kill it by clicking on this button, the red square, but I won't do this. Let it run. Now I go, so that's one JVM, right? Now let me go to the client. Come on, client. The client will be looking for this service, and we just did it. We started the service and registered it with the registry by using lookup. Over there we were using rebind on the naming service, but over here we're using lookup. The client wants to find it. Now we also need to configure args 0, right? Which symbol we want to pass. Right click, run configuration. Lesson 25. No, this is the wrong one. I want to run client now. Arguments. What are the arguments? IBM, for example. And. Apply. Let me close it. And. Over here. See, we need to pass the parameter to the JVM as well, saying where is the security file that specifies security policy, who can connect. And let me show you where I would put this in Eclipse. This argument was for our application, right? Program argument. But the other one is for the JVM. So you have to put it in this box. VM arguments. Apply. Now we can run the client. Invalid Nasdaq symbol. Man. I ask for the IBM price, but my stock quote server doesn't know about IBM. It can only give me this, and this. By the way, MOT is not valid either, but it's beside the point. We are not in the business of placing trades, right? Let me change it. Let me specify one of these. AMZN, Amazon. Run configurations. Argument. I want for Amazon. AMZN. Now it's a different story. Now it gave me this fake price of $29. But the point is that the client works with a proxy, right? It calls a method on a proxy, and the proxy communicates with the remote server. The whole thing is done using lookup in the registry. That's the main difference between the stock server and the RMI. With the socket server and the RMI server. With sockets, you need to know exactly where is your server, and you directly connect to the end point, we call it, the end point of the socket server. In the RMI, you do a lookup in the registry, and then you call stubs on the client. I guess we reached the end of the lesson successfully. So from the textbook, you need to read stuff in lesson 18 and 25. And I gave you something else, and if you get bored, you have nothing to do, you want to do something else, you want to read something else, read about all these Yahoo data, RMI, and I also added you a couple of videos, links to the videos. Look at the how the testing is done in Java. JUnit. There's another framework. I didn't put a link over here, but it's called Spock. So what is this thing? The thing about unit testing? It's just for to be a well-rounded Java programmer. Thank you very much for coming. This is Yakov Fein with Farada Systems. I hope I'll see you again next week.